All right, Algebra 1A students, welcome to part 2 of our lesson 5-6. In the last video we talked about parallel lines, slopes of parallel lines, and how we can write equations of parallel lines and what to look for that. In this video we're going to talk about slopes of perpendicular lines, which as a reminder for you, perpendicular means lines that intersect to form a right angle, which also means a 90-degree angle, like you can see here in this picture. These two lines intersect to form a 90-degree angle. They're called perpendicular. So what we're going to look at today is how the slopes of these lines are related and how we can write equations for perpendicular lines. So the first thing we have to understand is the slopes of perpendicular lines. They have a special name, a special relationship that's called being opposite reciprocals. Okay, opposite reciprocals. Slopes of perpendicular lines are opposite reciprocals. That means two things. The word opposite here means opposite sign. It means we have to flip sign from positive to negative. Flip positive to negative. Okay, so opposite means to flip positive to negative, and the reciprocal part means we're going to flip the fraction, the slope fraction that we have over. So we flip the top to the bottom. Okay, so two things we have to do in order to find opposite reciprocals, and that is to flip the positive to negative, or negative to positive, of course. You just flip the sign, and flip the fraction top to bottom. Okay. So as an example, if I look at negative 4 over 3, and I have negative 4 over 3 as my slope, and I want the opposite reciprocal, I'm going to do two things. First thing is I'm going to flip the negative sign to be positive, and then I'm going to change this 4 to be a 3, because that's what's on the bottom, and I'm going to change this 3 to be a 4, because that's what was on the top. So I've now found the opposite reciprocal. So we change the negative to be positive, we flip the 4 and the 3 over to make the reciprocal. Okay? So if we are told that we want, let's say, a line that's perpendicular to this equation right here, well, the first thing we have to do is identify the slope of this equation and then find its opposite reciprocal again. Okay, opposite reciprocal. So the slope of this equation is right here. It's 1/3. Right, 1/3 is the slope. So if I take 1/3 and I make the opposite reciprocal, first of all I will make it negative, and then I will flip the top and the bottom of the fraction. So instead of being 1 over 3, I'm going to have negative 3 over 1. Now, of course, over 1 doesn't really mean much. So what I can do then is I can just write my slope as negative 3. So immediately, because of the opposite reciprocal slope rule, I know that the perpendicular line slope is going to be negative 3, which means it's got to either be C or D, because those are the only two that have slopes of negative 3, right? Negative 3's attached to the x. That's where we see the slope attached to the x, in front of the x here, in front of the x. It's negative 3. So C or D is what I'm deciding between, and I have to figure out, okay, which one is this going to be? Well, they tell me that it passes through the point 2, 4. So I can write an equation in point-slope form for this relatively easily, because I know point-slope form is going to start y minus 4, right? Because 4 is the y-coordinate of this line, or this point, sorry, that I'm going to go through. So I start y minus 4, It equals, what's my slope? -3 was the opposite reciprocal slope that I found. Then in parentheses, x minus 2, close parentheses. Okay. So in your homework, I'm totally okay with this form of a linear equation right here. Okay, but in this case, for the multiple choice problem, I have to use the distributive property to get rid of these parentheses. So I times -3 by x, -3x, and I times -3 by -2, which gives me plus positive 3 times 2 is 6. And then this side says y minus 4. And then to get it into slope-intercept form, all I have to do is add 4 to get the y all by itself. And end up with y equals -3x plus, and 6 plus 4 together makes 10. So D would be my choice for this equation. Represents a line passing through 2, 4, right? Because that's why I wrote my point slope form, and it's perpendicular to this graph, and I know that because the slope is the opposite, meaning negative, reciprocal, flipped over version, -3 over 1, okay? -3 over 1. Now, the other thing that we're going to need to be able to do in our practice problems is to look at some two equations with x's and y's in them and decide if they're parallel, perpendicular, or neither. Okay, parallel, perpendicular, or neither. So what we have to do in order for us to see whether they are parallel, perpendicular, or neither is to be able to see both of the slopes. Meaning we have to get the y all by itself, or have the equation written in point slope form where we can see the slope in front of the parentheses. Okay, so if I'm looking at these two equations right here in letter A, if I'm looking at these two equations, I can identify the slope of this first equation right there as 3/4, because that equation is in slope-intercept form, so my slope is 3/4. The other equation I don't know the slope of yet, so I'm going to have to find it. So I'm going to have to get the y all by itself. And the first thing I need to do to get y by itself is get rid of these 4 x's that are on them. So they're currently positive, so I move them to the other side by minusing 4x. And then my equation, since these are gone, just says -3y equals -4x. And then a positive 9 would be plus 9. Right? And still the y is not quite by itself. Now I just have to undo the multiplying that I see here. I have -3 times y. I have to undo that multiplying by dividing by -3. Dividing by -3. And then that's going to be gone. And what I have left is y equals, well, this is a fraction here, and a negative over a negative actually makes a positive 4/3 x plus 9. So now I can identify this slope as well. It's right here, 4/3. So I now look at this slope compared to this slope. And I just ask myself, are they 100% the same number? No, they're not 100% the same number. So they're not parallel lines. I can eliminate parallel as an option. Are they opposite reciprocals? Well, one of them is 3/4 and the other 4/3. So they are reciprocals, meaning I flip the fraction over. Unfortunately, both of them are positive, which means they're not opposite reciprocals. So I also eliminate the perpendicular option, which means the answer here would be neither. Okay, neither. If I look at this set of equations over here in letter B, the second equation already has the slope solved for it here. And then I need to get the y all alone in this first one. The good news is all I have to get rid of is the 6 that's multiplied on. So I divide by 6, and that goes away, and I divide by 6. And I get y equals, well, there's really a -1 in front of that x, right? -1 over 6 with an x on it, plus 6. Oh, no, just kidding, because I also have to divide that by 6, which I also forgot to do over here, dividing by -3. So that should actually be a -3. Oopsies. Sorry about that. So when I divide that by 6, I get not +6, but +1. +1 there. +1. I had to make sure I divide every single piece by 6. So now I can identify the slope of this line. It's right here. It's 1/6. And when I compare that to this one, I notice that these slopes are 100% totally the same. And if I have totally the same slopes, they're going to be parallel lines, right? That's what we learned in our last video. So those two are parallel. So we're kind of combining our videos here in these problems to identify whether the equations that you're given are parallel, perpendicular, or neither. If you have questions about either of these, parallel, perpendicular, or lines that are not either of those, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.